Welcome to today's Living Lab lecture on Situating AI in Personalized Education. Great to have you all here. I'm Sandra and I've been working at ScaDS since April 2023. I'm an educational scientist with a special focus on teaching and learning research in the context of AI-based educational technologies. I'm the head of the junior research group Situating AI-based mentoring. And I'm also excited to introduce you to my brilliant research team. Mana is an educational scientist and a psychologist, and Gitanjali and Abbas are our AI developers. Together, we work on the creation of a personalized AI assistant for target-oriented learning in the form of an avatar. And this brings me to our new team member. Just a few days ago, Sam joined us. Sam is responsible for science communication in our team and has kindly offered to take over today's presentation. Thanks, Sam. I'll hand it over to you now.
Thanks, Sandra. I'm really excited to be part of this team and to work on such an exciting project, and I hope to meet all of you in person soon. I would now like to give you a brief overview of our collaborations. Our network is also interdisciplinary and international. For example, University of Florida, Harvard University, Curtin University, University of Southampton, and University of Mannheim. Additionally, we work closely with the EU projects like Vision, Contessa, and Tech4Comp. Here's a quick rundown of what we'll cover in today's workshop. You already know my team. We'll discuss AI in education, then I'll walk you through the basics of our research, touching on both the educational and technical sides. To wrap things up, I'll share 3 of our latest studies. The idea of using technology to support and personalize learning in the classroom is not brand new. Back in the 1950s, Skinner came up with the teaching machine to make classroom learning better. Even though Skinner was a behaviorist, it's pretty surprising this idea came from him. He wanted to tackle issues like students learning at different speeds and not getting feedback fast enough because teachers couldn't give everyone personal attention. Since having a tutor for every student wasn't realistic, he introduced the idea of programmed learning, which he put into action through his teaching machines. Learners got instant feedback for correct answers, helping them stay on track. Mistakes were corrected to boost the chances of getting it right next time. Skinner wasn't trying to replace teachers with machines. His whole approach was based on his learning psychology, specifically the idea of stimulus-response reinforcement, which is actually operant conditioning. He believed learning should happen in small steps, with rewards at each step, so students could learn at their own pace. These ideas actually set the stage for today's adaptive learning systems. Ever since ChatGPT and other generative language models hit the scene, especially at the end of 2022, AI in education has really gained steam. By now, we're all familiar with tools like Grammarly for improving writing or Duolingo for personalized language learning. Even Gradescope is helping teachers speed up grading. Most studies focus on how AI is being used in things like academic writing, research, and exams in schools and universities. But there's still not much out there about how AI is actually changing education on a bigger scale. But while these tools are great, it's also important not to lose sight of what education really should be about. Humboldt saw education as more than just hitting performance targets. It was about developing yourself, your skills, and living a self-determined life by connecting with the world around you. In contrast, today's focus tends to be on meeting specific, measurable standards and fitting societal demands, which can feel limiting. Education critics like Haydorn argue that this approach prevents people from fully developing their potential, and that's something we shouldn't forget, even as AI becomes more central in education. AI in education has huge potential to move beyond the one-size-fits-all model and create personalized learning experiences. It can adapt content and pace to each student's needs, making learning more engaging and effective. Theories like constructivism, self-determination, and situated learning highlight the importance of active, social learning and student autonomy. In this setup, AI and teachers work together, with AI offering personalized support without replacing educators. This boosts self-regulation, motivation, and engagement. But we also need to consider challenges like data privacy, AI acceptance, and making sure content stays diverse. Plus, there's the balance between AI taking over tasks and the need for upskilling and reskilling. Gabby Reinman points out key shifts in skill development with the rise of AI. First, there's dekilling, where humans lose certain skills as AI takes over tasks. Then there's upskilling, where we build on existing skills to keep up with new tech. Lastly, reskilling involves learning brand new skills to adapt to changing roles. These changes highlight the balancing act between tech advancements and maintaining important human abilities. Now, let's move on to the foundational research of our research group. We're working to tap into the power of AI to make learning more personalized and effective, with a focus on AI-driven mentoring in higher education. Our goal is to improve the mentoring experience using AI tools like machine learning, natural language processing, and deep learning. To do this, we're creating an AI-powered conversational mentor, which will be the key feature of our user-focused platform, a learning record store. With an AI-guided interview, we create a personalized profile and portfolio for each learner. The interview is language-based, and in the first part, the assistant asks questions about things like demographics, interests, and experiences. It's just the start of getting to know the learner. This profile is dynamic and adapts over time as the learner grows and their needs change. The resulting portfolio showcases the learner's competencies, including formal qualifications like academic degrees, informal ones like hands-on experience, and non-formal qualifications from extra training. It also highlights the 4 Cs: creativity, collaboration, communication, and critical thinking. The information collected during the interview is then compiled into a personalized profile. The AI assistant helps identify goals and breaks them down into smaller, clear learning objectives. We make a distinction between big, general goals and the smaller steps needed to reach them. This way, mentoring is tailored to help you hit your targets. For instance, if a future teacher has the goal of getting better at classroom management, the assistant might suggest specific objectives like learning conflict resolution, creating clear classroom rules, and boosting student engagement. The next step is to identify which competencies and skills are needed to achieve the learning objectives. Next, the AI assistant uses the learner's profile, defined goals, and learning data from the learning record store to provide personalized support and guidance throughout the mentoring process. Our AI assistant is designed with some key principles in mind that put people first. We prioritize human needs and well-being, aiming to help individuals fully unlock their potential. The advice is personalized to each person's unique goals and preferences, no one-size-fits-all approach here. Accessibility is a top priority, ensuring that anyone, regardless of their background or characteristics, can benefit from the assistant. The guidance provided aligns closely with the specific objectives of each user, making sure it stays relevant to their goals and current context. We also consider the broader cultural and social influences that might affect decision-making, ensuring the advice is well-rounded. Throughout the whole process, the AI provides consistent, structured mentoring, offering a unified experience that helps users stay on track. It's like having a mentor who really gets you and is there to guide you every step of the way. Our AI assistant is built to cover 4 main functions that make the learning process smoother and more personalized. First, there's the reactive function, where the assistant answers students' questions. If more explanation is needed, it jumps in to clarify things. Next, we have the proactive function. When the assistant can't answer a question, it passes it straight to the instructor. Plus, it keeps students on track by reminding them of important deadlines and suggesting extra learning materials, both inside and outside the course. Then there's the evaluative function, which is all about providing continuous feedback. The assistant tracks learning progress, analyzes data, and points out areas where students could improve. Finally, the adaptive function makes sure the assistant gets smarter over time. It updates the course content based on student questions and fine-tunes its answers by learning from past interactions. It's like having a learning buddy that grows with you. Let me give you a quick rundown of how our system works, starting with user interaction. Users can either upload their resumes or chat with our chatbot to kick things off. This helps create a personalized profile and set specific learning goals. Next, we use natural language processing, NLP, to analyze the information. By applying techniques like tokenization, named entity recognition, sentiment analysis, and intent detection, we can process the data effectively with tools like ScaDS.AI, NLTK, and transformers. From there, the system builds a personalized profile based on the resume or chatbot conversation, using that info to define tailored learning objectives. We also use a RAG mechanism to provide relevant and accurate responses. It pulls in the right info and generates answers with transformer-based models, ensuring accuracy. With the profile and goals in place, the system recommends personalized course materials. It keeps track of the student's progress with quizzes and tests, spots any learning gaps, and offers extra resources to fill those gaps. Performance analysis and feedback are key parts of the system. It evaluates how well the student is doing and collects feedback to keep improving both the learning experience and the AI itself. Lastly, the system provides visualization and reporting, offering dashboards and data insights to help with decision-making. This ensures that the system evolves with the user's needs, constantly improving recommendations and overall effectiveness. Our platform features a personalized recommendation engine that suggests learning resources based on each student's goals. An LRS tracks interactions, outcomes, and feedback, allowing for continuous progress monitoring and adjustments. We use RAG to personalize recommendations, fine-tuning them with query expansion and relevance feedback for precise results. The system also analyzes performance through quizzes and tests, offering extra resources when needed for targeted support. User interaction is straightforward. Students ask a question, and the system retrieves relevant information, processes it, and delivers a tailored response, ensuring helpful and accurate answers. Let's break down how our AI-driven profiling system works. First, we use NLP techniques like tokenization, sentiment analysis, and entity recognition to understand user inputs and build detailed profiles, using powerful frameworks like ScaDS.AI and transformers. Next, RAG helps us pull in real-time information from external sources and generate accurate, context-aware responses using transformer models, enhancing responsiveness and creating deeper interactions. We also use DNNs, fine-tuning models like BERT and GPT to ensure that conversations are coherent and perfectly aligned with each user's educational needs. Lastly, we incorporate federated learning, which allows decentralized training on local devices, ensuring privacy while reducing latency. We still aggregate model updates to improve performance globally. All these techniques work together to create a smart, secure, and adaptive learning environment that evolves with each user's needs. Our platform offers a personalized recommendation engine that tailors learning suggestions based on each student's goals. Instead of just tracking interactions, our learning record store keeps a close eye on the learning process, monitoring progress toward goals and offering formative feedback when needed. This feedback isn't about giving direct answers, but guiding students toward solutions through questions, prompts, and suggestions, all rooted in a Socratic approach. Retrieval-Augmented Generation helps personalize recommendations by pulling in relevant learning data, but the system doesn't just hand over information to be copied. Instead, it sparks deeper thinking and encourages learners to explore their own solutions. The platform focuses on ongoing learning analysis rather than constant assessments. When gaps or challenges are identified, the system suggests extra resources and strategies to help students move forward. It's all about offering timely support, adapting the learning path based on individual progress, and giving feedback that helps learners reflect and grow. As for interaction, it's simple and thoughtful. Students ask questions or share their thoughts, texts, or concepts, and the assistant guides them by suggesting new angles, asking thought-provoking questions, and encouraging deeper exploration, always pushing toward active learning and understanding, rather than just delivering answers. This slide shows how user queries are enhanced through prompt augmentation by incorporating previously retrieved content. It also provides a clearer view of the retrieval process using semantic search, and how the LRS, with data sources, document chunks, and a vector store, works together to find and generate the most relevant response. And to conclude, I'd like to briefly introduce 3 of our recent studies that we have published. Here you can see an overview of all the data we are currently working with or plan to work with in the near future. Due to time constraints, I won't focus on every single item, but I'd like to highlight 2 key datasets that we are already working with or have planned for data collection. We have developed an online questionnaire based on the 14 areas of the AI-based interview to create a learner profile. We use this data, among other things, to train the model. Additionally, we are working with data from a needs analysis, where 145 students were surveyed using questionnaires and focus groups to explore the role of AI in qualification, self-directed learning, and socialization. A planned data collection will include screencast recordings using the thinking aloud technique, as well as the method of learning diaries, to examine the current role of AI in higher education. In this study, we explored how AI avatars can be effectively designed to enhance learning in higher education by using an online questionnaire. We identified 5 key factors that play a major role in shaping AI-supported learning: adaptive individualization, representation and identification, real-world relevance and context, role variation, boosting self-efficacy. These elements are essential for making AI avatars truly effective in supporting self-regulated learning processes. These 5 factors are crucial for effectively using AI avatars to support self-regulated learning processes. In this study, we set out to explore the current state of personalized learning frameworks and algorithms. To do this, we used a 2-part approach. First, we reviewed existing literature and collected data from platforms like MOOCs. Then, we evaluated how AI models are being used in educational platforms, focusing on key metrics like precision, recall, AUCROC, BLEU, and Rouge to measure their effectiveness. Our results show that AI-driven frameworks like NCF and GPT greatly improve the adaptability and efficiency of personalized learning systems. These advanced models can tailor educational experiences on a high level. However, we also found some challenges, such as data privacy issues, high implementation costs, and the complexity of integrating AI into current educational systems. In our study, we looked at how AI-based educational technologies can integrate differential privacy while still delivering personalized learning experiences. To tackle this, we created a trustworthy AI mentors framework that combines advanced models like GPT-4, GPT-3, Mistral AI, Llama 2, and BERT with privacy techniques like noise addition and secure multi-party computation to keep data safe. We also used advanced NLP techniques like named entity recognition for context-aware responses. Our findings show that GPT-4 improved accuracy by 15% over GPT-3, and Mistral AI stands out in real-time applications. Llama 2 is more resource efficient, using 30% less than GPT-3 while still keeping accuracy high. Privacy techniques like noise addition and federated learning with SMPC successfully balance data protection and performance. We've now reached the end of our presentation. Thank you all for your attention. Here you can find our group's contact information. We look forward to further discussions or any potential collaborations. Now, I'll hand it back to Sandra and my colleagues, who will be happy to answer any of your questions.